Now we move to our third speaker, Mr. Luke Johnson, a solar engineer with over 19 years of experience. Luke holds a Master's of Philosophy in Engineering, Solar Cell Research from the Australian National University, and a Bachelor of Engineering in Photovoltaics and Solar Energy from the University of New South Wales. Mr. Luke is the founder and CEO of SunPulse KK and Liquid Star Limited, and has completed well over 10,500 megawatt peak of design and technical due diligence on 1,280 plus solar photovoltaic plants in Japan. Focused on solar irradiance analysis for Japanese solar plants, PV cyst and yield analysis. In addition to the above, he has designed over 30 operational solar power plants using AutoCAD Civil 3D and PVCase. The largest solar power plant in operation is 25.8 megawatt peak DC in Kyushu, Japan. Since 2014, working on data logging of solar power plants data feeds on blockchain technology, including the use of solar coin, Ethereum, and NFTs. Luke will be presenting on renewable energy certificates, accounting for externalities of power. Engineer Luke, the floor is yours.
Thank you very much. Can everyone hear me? Thanks, Yazan, for your kind introduction. And thanks to all the other speakers. That's really interesting. And I'm taking a lot of notes, learning a lot. Thank you very much. So I'll just share my screen here. Hopefully that will just work now. Can you see that screen? Yes. All right. So to switch to speaker view. So this presentation is about renewable energy certificates and accounting for the externalities of the power produced. So I'll just go through a quick introduction of what we actually were commissioned to do. Secondly, the certificate platform, a little bit about the back end and also the front end of the platform, some of the user interfaces, and finally going to the conclusions on the future of this platform. So on commission of the Kingdom of Bahrain and the UNDP, starting about mid-2019, we started to look at this proof of concept program for a blockchain-enabled IoT-connected solar power plant renewable energy certification program. So that's a little bit of a long sentence there, but basically we were commissioned to look at how you would connect IoT to the blockchain, and then build the complete renewable energy certification program. So it consisted of three parts: the IoT data logger, the backend stack that passed the data to a local server, and the connection to the Ethereum blockchain from the server, so the SEA could certify and produce a non-fungible token on the blockchain for the exact solar energy that was produced by that solar plant in Bahrain. So it was very important to leverage some of the excellent benefits that blockchain provides with the provenance of your data source. And that's something that I'd like to highlight in this talk. If there's one thing I'd like to highlight, and that's it. So a little bit about the setup that we produced for this proof of concept. So starting about 2014, SunPulse started to heavily research blockchain and data logging. So we quickly realized that there was a very good technology base with blockchain. If people are familiar with it, it's just like a distributed database that anyone who does a certain amount of work can interact with that database, if that's the case of a public blockchain. There are other types of blockchains, but I'll talk about that a bit later. So in the case for us, we use the Ethereum public blockchain, and it could actually be used with other similar blockchains of the structure of Ethereum, but in this case, we used Ethereum. So what we did was we produced our hardware and the software stack that connected to the monitoring system that you usually find at a solar power plant. And from that, we made a secure data pipe. That secure data pipe can then go through our backend stack and then interface with continuous process to push a renewable energy certificate onto that blockchain. So it's basically a way to solidify the results that come out of that solar power plant and put them into a non-fungible token. And so that non-fungible token has a very good provenance of the data source that is coming directly from the solar power plant. So in the case for the proof of concept, we are able to split it up into two categories: a secure data pipe for the ministry itself, and the secure data pipe for putting the small data logger device on some of these solar power plants. So one of the other aspects of this was using building a public user interface so that the public in Bahrain eventually would be able to track their certificates that are being produced by the ministry, SEA, so that they could be following the creation of these certificates and the retirement of these certificates, and just following all of the traceability of what happened when that certificate was produced or that was retired, who owned it, some of the aspects of how it was produced, and all of these important encapsulated data. So this, just a little bit going into the background of why we did this. We wanted to basically make sure that the provenance of the data source is kept to the best ability of the latest technology with IoT and blockchain together. So if you flip back to this slide, there is this thing called the ZB hardware. This ZB hardware is a way to really make sure that the data source and the inverter is channeled correctly, one-to-one ratio onto this public blockchain. So there's no any kind of attack vector to reproduce this data or duplicate this data or pollute this data source. So that has been the biggest challenge since we've started the research and development of data logging with blockchain and solar power plants since 2014. So luckily by 2019, we're already quite deep into this aspect of the hard problem to solve, and we're ready to scale it up for this proof of concept phase for Bahrain's and the ministry's case. So we were able to overcome that problem, and we're ready to scale it up further. So one of the triple trade-offs with writing to a blockchain is there's three things. There's the scalability, the security, and the decentralization. Naturally, with the triple trade-off, you've got, if you go to one of those areas, you're compromising some of the other areas. So if you're solving for scalability, you're lessening your decentralization, or if you're solving for security, you're lessening your scalability, and so on and so forth. Luckily for this proof of concept phase of this program, we were working with the ministry, and the basic tenet of this project allowed us to compromise some of the decentralization aspect to optimize for security and for scalability. So we wanted to leverage the main benefit of the blockchain so that we'd basically keep the provenance of that data source and using our data logger technology. So this is the example of the output of a platform. So what you see there is a renewable energy certificate that is generated. It's just in the proof of concept. But over here, we have the public user interface on the left-hand side. And that you are able to zoom in and click and find out the information about what happened with that data source, the company, the individual name, commercial registration number, when the period was beginning and ending, and for how many megawatt hours was produced by that solar power plant. So that renewable energy certificate is actually an equivalent token on the Ethereum blockchain, according to an Ethereum standard for non-fungible token. What I mean by non-fungible token means it's very absolutely, it cannot be mixed in with other tokens and mixed around. So it's got a very good traceability to that data source, to that solar power plant, to that data logger number, to the person who actually produced that in the ministry as well. So that's the complete non-fungibility of that token. And this is something that is quite developed now on the Ethereum public chain with a lot of non-fungible tokens. Maybe you're familiar with a lot of artworks that are starting to be sold and reproduced around the world as non-fungible tokens. That's only one aspect of this new technology that's come out. So with the backend stack, there's actually about many parts, but just to summarize, the main deployable data logger is at the solar power plant, depending if they're on a certain size. There's an API that connects the data logger to the cloud aspect. There's the administrator user interface, naturally, for any kind of program like this. There's the Bahrain government's user interface for making sure that you can produce and retire and mint these certificates. There's also a public user interface where everyone can basically get their login and have a look at what's happening with the whole renewable energy certificate program. So when the associated person in the ministry or the SEA is going to actually mint or retire the RAC, this is actually an interaction with a thing called a smart contract. So if you feel a familiarity with a smart contract, it works with a public blockchain, and it's got a certain set of rules and applications that are produced under certain conditions. And outside these, there is nothing really that you could go around to undo that smart contract. So the physical unit is just a small device that can be placed in an IP67 next to an inverter or at a monitoring center of the solar power plants. In many cases, solar power plants have areas where IP67 boxes can be produced, and it's got a certain temperature rating from -6 to 45 degrees and without any additional cooling. However, it would be good to place it near other equipment that have a similar IP67 rating and also cooling and heating requirements. So this is an example of the data logger stream. So in the data logger, every 5 minutes, it checks a certain number of cryptographic functions about the data source. And then it signs that with its own unique cryptographic function. Then it checks that signature. So if that signature is valid, it gives it a green tick and says everything's great, that this data is valid. There has been no interruption to this data feed. If there is a problem where someone opened the box, they trips the perimeter detect circuit, and so there's been a tampering with the box, then that actually destroys the ZB data feed, and basically it turns off and it says, oh, this is invalid signature. And in that case, there would be like a red cross there. If you're going to produce the actual renewable energy certificate that is done at the ministry level, then you go through these data feeds, you export it, and you import it to your smart contract platform. Then you can interact with the actual platform to produce the NFT. You cannot produce the NFT from the same data twice because it's non-fungible. And also if there's any expired data there, you wouldn't be able to produce that. So just in winding up to some of the further aspects of this program, from our understanding, this is the first plug and play in the world stack for the exact provenance, traceability, and tradability of these RACs using the Ethereum blockchain with a government-backed minting and retiring of those NFTs. There may be other programs that we are possibly aware of that are using RACs on public blockchains, but they're using a number of different methodologies, and in some cases using different blockchains. There is the scalability function that is very important to note about the Ethereum blockchain. At certain times of the year or the day, the Ethereum blockchain itself gets very busy. So interacting with that blockchain, the cost of interaction is called a gas price, does change. And it's very important to monitor this and make sure this is budgeting into any interactions by the ministry when they're interacting with this smart contract. The Ethereum blockchain as well is evolving, and there's hundreds of thousands of developers all around the world constantly improving this public infrastructure actually. And one of the phases of that is to improve the scalability of this blockchain by moving from a traditional mining methodology, which is highly energy intensive, over to another thing called a proof of stake technology, which is much more energy efficient. So that is one of the things that Ethereum uses, but our actual platform can actually work with different blockchains as well, because we've got an API that can interact with those different cases. For example, EWT chain, or in other cases, Solarcoin and other ones. So the NFTs that are produced are an excellent package that is neatly tied up to show the provenance and the tracking of the RSEs in using the decentralized public blockchain infrastructure. So that data logger has been in development continuously since about 2013. So we're very happy to go through this POC with SEA and UNDP and make continuous improvements to follow. If you need to talk about any of the technical details, please reach out to me. There's also a link here that you can look at later. The next step for us is currently improving how we treat the authentication token. In that next iteration, we will make it much harder to eavesdrop on any of the connections by encapsulating the authentication token only at the local server side. The local server side can then be developed at a bare metal for the client or various instances online, depending on the client's needs and security profile. So this is really important for us to make sure that the security is the utmost. And we're actually getting third-party checks as well about our security profile and authentication tokens within the stack, and when we go to interact with the smart contract as well. So there will be a continuous rollout, possibly subsequent to approvals of this program to other solar plants that we're looking at initially in the proof of concept phase. So at the last part, we will also work with the localization of the public user interface for language and any of the public user needs for Bahrain, and looking forward to developing this further. And hopefully that's the end of my presentation. So thank you very much for your time, and I'll stop sharing my screen.
Thank you, Luke. Another interesting presentation. I think you have incited all of us to learn more, educate ourselves about these new projects. And I'm happy to hear that the SEA is really involved in such a concept and the work you're doing to